Hello everyone. So in today's class we are going to study the orthogonal property of Legendre polynomial. Orthogonal property of Legendre polynomial. Polynomial. Alright. So the orthogonal property says integral -1 to +1 Pmx and Pnx into dx is equals to 0 if m does not equals to n and 2 upon 2n plus 1 if m is equals to n. So this is the orthogonal property of Legendre polynomial, where Pm, Pnx are the Legendre polynomial. Alright. So as we know, the differential equation for what Legendre polynomial is given by 1 minus x square d square y upon dx square. We already know this. Minus 2x dy by dx plus n plus 1 y is equals to 0, where n is some integers. Alright. So these two terms I can write it as well, d upon dx of 1 minus x square dy by dx plus this is as it is n plus 1 y is equals to 0. How? Just let me do it. Okay, let me explain this why I written this one. Alright, so let's derivate this one. Alright, just do it with I'm doing with a different color. So if I differentiate this is first function, this is second function. Alright, with respect to dx, for first function it will be constant. I'll treat it as a constant. For if I differentiate this second term with the spectrum, so this becomes dy upon dx square. Alright, then after plus of as a second function dy by dx as it is, and differentiation of this one becomes what? Minus of 2x. Alright, so I can write it as 1 minus x square d square y upon dx square minus of 2x dy by dx. Alright, so that's why I've written these two terms in short form. Alright, in differentiation form. Good. So I can write this differential equation in terms of d upon dx 1 minus x square dx. So this is just an explanation. So what was the final result? The result was I can write differential equation of Legendre polynomial as d upon dx 1 minus x square dy by dx plus n plus 1 y is equals to 0. Alright, where this is n, we see y is the solution. Solution was what? Pnx. Be the solution. We already know the solution of this differential equation is Pnx. See this equation 1. Alright. Okay. Just include this y. Just substitute Pn instead of y in this equation. Alright. So the final equation becomes, Legendre equation becomes d upon dx 1 minus x square d upon dx of instead of y I will write pnx. Alright, pnx plus n plus 1 pnx is equals to 0. Say this is equation 1. Alright, so I have converted the differential equation in terms of Legendre polynomial Pn. And for orthogonality property, we need two Legendre polynomial Pmx and Pnx. So I need one more equation. But just replace n by m. Alright. So d upon dx of 1 minus x square dpmx upon d over x plus m plus 1 pmx is equals to 0. This is equation number 2. So we have two differential equation in terms of pn and pmx. Alright. Now just multiply pm in this equation and subtract with, just multiply. Okay, let me write, just do this condition. Multiply pmx in equation 1 and pnx in equation 2 then subtract equation 1 and equation 2. So the final version will just I said pmx is multiplied by equation 1, alright, minus pnx with equation 2, alright. So pmx is multiplied by what? Equation 1 was over 1 upon dx, sorry, d upon dx 1 minus x square 1 minus x square okay, just erase this 1 minus x square d upon dx of pnx, alright, minus plus of n plus 1 pnx is equals to 0, alright. So here we have two equations, so let me just remove this 0. So this is our first, I just multiplied pm with equation 1 minus of pnx with d upon dx of 1 minus x square dpmx upon dx plus of m plus 1 pmx, alright, which is equals to 0. Now just multiply pmx inside and separate the differential equation term. So the result will be pm. First term will give me pmx. Okay, I just write pm and we will know that pm is a function of x just for simplification. Alright, so pm is a function of already x, so I'm not writing individually x here. So just multiply dy by dx of 1 minus x square del of pn of only pn upon dx. Good. First term, and this term will give me what? Minus of pnx differentiation with respect to 1 minus x square del pm upon del x. Another term will be this one. So this term will be pm multiplied by pn pm n plus 1. Alright. So this will give me plus n plus 1 pm. Alright. Minus this side will give me minus of what? m plus 1 pn. Alright. Which is equals to 0. So just simplify this. So the first term pm d over dx 1 minus x square dpn upon dx as it is minus pn del over del x 1 minus x square dpm upon dx as it is. Now simplify this. I know pm and pn are common. Just negative and take it common and multiply by something at common. Pm and pn as common, and the left quantity is this becomes minus of m square as I taken minus and common, so this becomes positive m square. Then this term will be minus minus plus m plus of m, and this become negative y because I have taken negative sign common. Minus of n square minus n is equals to 0. Alright. Now integrate this equation. Integrate above equation. Okay. We can do some modification too. Just take this term right hand side. What is which term? This term right hand side. So the final result will be pm del over del x of 1 minus x square dpn upon dx minus pn d over del x of 1 minus x square dpm over dx is equals to this is negative, so this become m square plus m minus of n square minus n pm pn. So now differentiate, integrate this. Integrate the above equation. Integrate the above equation with respect to x. For limit minus 1 to plus 1. Alright. Minus 1 to plus 1. We will take the limit and we will integrate both the side. So first term will give me what? Integral of minus 1 to plus 1 of what? Pm del over del x of 1 minus x square dpn upon del x multiplied by dx minus 1 to plus 1 integral minus 1 to plus 1 pn del over del x summation 1 minus x square del pm upon del x into dx. Alright, and right hand side will be right hand. This is common, this is constant, so I take it. I can write it what mn and m square and n square can be written as m minus n, m plus n, and the left quantity is m minus n plus m minus n. Take this in bracket. Good. Integral minus 1 to plus 1 pn and pn into dx. Why pn and pm on pn and are the function of x? Alright, so integrate these terms by part. Alright, so using by part method. All right. So this will give me first term will give me, treat this as 1, and this is second function. All right. So Pm will be as it is, constant. Then this must be integration of this first function into integral of second function. Integral of second function give me minus x square of dpn upon dx for what? Minus 1 to plus 1. Good. Minus of integral minus 1 to plus 1. Differentiation of this. Differentiation of first function. Differentiation of first function is Pm. Alright. Then integral of this function. Integral will give me what? 1 minus x square pnx dpnx upon dx into dx. Good. For the second term, this term negative sum already. So we have negative of this will become Pn will be treated as constant. Integral of this function will give me what? 1 minus x square dpm over dx. Alright. For limit minus 1 to plus 1. And then after minus and minus will give me plus sign. This minus term. Alright. So the integral will convert into plus term. Integration minus 1 to plus 1. Differentiation of first function. Differentiation of first function is d upon del x of pnx into integral of first function. Integral of first function will give me 1 minus x square dpm upon del x into dx is equals to this term. This is constant, so I can take m minus n common from both the sides. M minus n common, so the left quantity will be m plus n plus 1. Good. Integral minus 1 to plus 1 pm pnx dx. Good. As we can see, these two terms are same. Minus integral del pm upon del x 1 minus p square pnx upon dx, and we can see minus 1 to plus 1 del pm upon px 1 minus x square del pm x square. These are non multiplication, so this is nothing changed, so this is common, so this will cancel out. And as we can see here, if I substitute the plus value here, so this will give me 0. Why? 1 minus x square, so 1 minus x is plus 1, so this will give me a minus 1 is again 0. So whether I put plus 1 and minus 1, this term will give me 0 for upper limit and lower. Same is it here. If I substitute the upper limit, this will give me 0, and if I substitute the lower limit, so this will give me again 0. So this is again 0. So the left hand side is completely 0. So the left quantity is, I take it this m minus n m plus n plus 1 integral minus 1 to plus 1 pm pnx dx is equals to 0. Why? Because the left hand side is all terms are 0. So when you can say if m and n does not equals to are same, then we can say this term is just to satisfy this equation, we can say minus 1 to plus 1 pmx pnx dx is 0. This is the first property, orthogonal property of Legendre polynomial. All right. For just to prove the second one, when m is equals to n, so we can't find here, so we will do the another derivation just to prove when m is equals to n. So this is the first orthogonal property which has been driven. All right. So the second, when condition is when m is equals to n. So as we know the generating function, as we know the generating function of Legendre polynomial What is the Legendre polynomial? Generative function 1 minus 2x plus z square to the power half is equals to summation and tends to 0 to infinity z to the power n pnx. Alright, this is squaring both sides. Squaring both side. Squaring both side will give me what? 1 minus 2xz plus z square to the power minus 1 is equals to summation and tends to 0 to infinity z to the power n pnx the whole power 2. Alright, so I can write it as 1 minus 2xz plus z square is equals to, first term will be p0, then second term will be z1 p1, then after z2 p2, then after z3 p3, and so on to the power 2. Good. So I have opened this summation form. So when we do the square of this summation series, so we will get two terms. One term are of p1 square, p0 square, p2 square, and one another will be p to the power, okay, p1 p2 to the power, and if z is 1, z to the power z1 z plus z square, like this. So on expand, when we'll do the square of this, we will get two terms. First term will be, all right, first let me write 1 minus 2xz plus z square is equals to, on expanding this, we will get two types of term. One term will be square form, in a square form. So just write, I'm just writing n tends to 0, z to the power, all r will be term. If here it is okay, here is nothing, here will be z2, z4. Alright, so this will be z to the power 2n into pnx, and other terms will be z1 z2 p1 p2 plus multiple plus z21 z21 and other. For this quantity, some terms will be this p2 p1. All right, so these are we will have two kind of terms, so we will add these two terms, summation m comma n equals to 0, the summation to the power, so z to the power m plus n pm pn. All right, when m does not equals to n. So on expanding this series, this summation in series form and squaring this series, we will get two types of term. First will be on a square form, and another will be z m plus 1 terms. All right, now integrate just integrate both the sides. Integrate both side from limit minus 1 to plus 1. All right, this becomes minus 1 to plus 1, 1 upon 1 minus 2xz plus z square into dx, and okay, this will term summation n tends to 0 to infinity z to the power 2n integral of pn square dx, and this term will be 0. Why 0? We know integral, but on integration for a different, when m does not equals to n, the integral is 0. So this term is 0. This term, on integrating this term, this will give me 0 from the orthogonal property of Legendre polynomial. Alright, so we have summation n tends to 0 to infinity z to the power 2n integral minus 1 to plus 1. Alright, minus 1 to plus 1 pn square dx h equals to, on integrating this 1 upon, it will treat it as 1 upon x log formula. So this will give me log of 1 minus 2x z plus z square upon a is your 2x minus 2z. So the limit minus 1 plus 1. Good. So we will evaluate this. So this will give me what? Take 1 upon 2z as a constant. Substitute plus 1. When we will substitute the upper value, upper limit, so this will give me 1 minus 2 z plus z square. So this is nothing but 1 minus z square formula. Minus of this will give me plus. When I will substitute minus 1, so this term will be 1 plus 2z plus z square. This will be log of 1 plus z square. Alright. This term. Just take the square common. So this will cancel and it will come out in front of log. So 2 will cancel 2. So let me do. So this is minus 2 2z of log 1 minus z minus of log of 1 plus z. This will cancel out. Just multiply minus 1 inside. So this will come 1 upon z. This will become log of 1 plus z minus of log of 1 minus z. Good. So 1 upon z. I know 1 plus log 1 plus x is z minus z square upon 2 plus z cube upon 3 minus something. So minus of log 1 minus x is minus of z minus of z square upon 2 minus of z cube upon 3 minus 1. Alright. Now from here just take minus sign common. So this will become 1 upon z minus z square upon 2 plus z cube upon 3 minus 1 plus of z plus z square upon 2 plus z cube upon 3 and so on. Alright, I can see this term will be cancelled out and 4 term will be cancelled out and 16 even number terms will be cancelled out. So the left quantity will be now when we will add this will give me z 2z and we have here 1z in denominator. So on solving this we will get 2 common. First term will be what? Z and z cancel out, so this will give me 1 plus, then after, then we will have z3 and we have a denominator is z, so it will give me z square 3, then after z4 5 and this so on. Alright, so we will have this series. So on the left hand side we had n equals to 0 to infinity z to the power 2n integral minus 1 to plus 1 plus 1 plus 1 p square p n x square x into dx is equals to what? 2 1 plus z square upon 3 plus z to the power 4 upon 5 and so on. So if I will write this in summation form, so we will have 2 of summation n tends to 0 to infinity z to the power n z to the power, these are in 2 to the power form. In even terms 2 4 6, so we will have 2n and here is odd number, so we will have 2n plus 1. Good. So on comparing the coefficient of z to the power 2n, z to the power 2n both the sides. So we will have, here we have left this integral minus 1 to plus 1 p square n dx is equals to, here we will have 2 over 2n plus 1. So this is the second orthogonal property of Legendre polynomial. So what we had calculated, we have calculated today integral minus 1 to plus 1 pm pnx dx is equals to 0 if m does not equals to n and 2 upon 2n plus 1 when m is equals to n, or we can write it as integral minus 1 to plus 1 pmx pnx dx equals to 2 upon 2n plus 1 del of mn, where del of mn is Kronecker delta. Property of Kronecker delta is what? Delta mn is 0 when m, if m does not equals to n, and this is 1 if m is equals to n. So we can write this in the form of Kronecker delta. So this is for today. Thank you.